Howdy. In this video, we want to do what we call a U-substitution. We're going to factor this and we're going to introduce a new variable. So what we'll do, here's what I see. I see an x to the fourth, an x to the second, and then an x to the 0. Okay, no x's. What I'm going to do is I'm going to say let u, not me, but u equal, yes, that was a joke, u equal x squared. Okay, if that were the case, if u is equal to x squared, then u squared would be equal to, well, x squared squared, which is, of course, x to the fourth. So what I can do is I can rewrite this problem in terms of u, not me. So this u, that's another joke, I'm sorry. This becomes u squared minus 5u minus 36 equals 0. Well, this is something that's significantly easier to factor. Hopefully you recognize that this is u minus 9 times u plus 4. Let's double check to make sure that's right. When I say u, that's a 4u, that's minus 9u, that gives me minus 5u. We're good to go and everything else looks great. Okay, so what I have done is I have said that, well, it depends on if they tell me to factor or solve. They said solve. Okay, so what I can do is I can say, well, u has to equal 9 or u has to equal negative 4. But they didn't ask me to solve for u, they asked me to solve for x. But from back here, I know that u is equal to x squared. So this is now x squared is equal to 9, or x squared is equal to negative 4. Now I can do the cheer and say square root, plus minus, and I can do it here, square root, plus minus, and I find that x is equal to plus or minus square root of 9 is 3. And this one, x is equal to, when we try and take the square root of negative 4, we end up with an imaginary number. And so this is plus or minus 2i. So if they say solve, we're going to tell them that x can either equal plus or minus 3 or plus or minus 2i. If they had said to factor, it depends on how they say it. If they say factor over the reals, then that means that everything needs to still be a real number. But we could factor and say x minus 3 times x plus 3, and then we would have had to say x squared plus 4. Because this piece right here, when I had substituted back to x squared minus 9, that could factor farther. This, however, x squared plus 4, no longer, if I keep factoring that, I no longer stay real. If they had said factor completely, I can't spell, whatever, I don't care. I would say x minus 3 times x plus 3 times x minus 2i times x plus 2i. And this would be equal to my f of x, or if it had been equal to 0 or whatever. So this would be factor completely, or factor this. They might also say factor over the complex numbers. So notice they introduced complex numbers on this one, but we weren't allowed to have complex numbers here. Okay, so this was a U-substitution. It's a very handy trick. It definitely makes things, this problem wasn't super complicated, but sometimes they get really gross. And so, like if you had sine, I don't know, sine to the fourth of x minus 2 sine squared of x plus 1. Well, you're looking at this going, I don't know. Okay, so our u substitution would be that u could equal sine squared of x. Then this becomes u squared minus 2u plus 1, and that actually factors to u minus 1 quantity squared. And all of a sudden, life got a lot easier, and we got down to this sine squared x minus 1 quantity squared. This probably should have equaled something, but whatever. Okay, so that one was definitely a case where it looks a little more confusing and you have no idea what's going on. Don't worry, I'm going to teach you the trick later, but thought that would be helpful. Okay, go practice.